Hello guys, welcome to the video. So today we are going to see the problem number 231, that is power of 2. Given an integer n, return true if it is power of 2, otherwise return false. So we need to find that a given integer n is a power of 2 or not. So let's see what is the power of 2. And integer n is a power of 2 if there exists an integer x such that n is equal to 2 raised to x. So with that example, we'll see more clearly what is power of 2. So n equal to 1, correct? So x value is 0 here. So 2 raised to 0 is equal to 1, correct? So we are returning true here. So we need to find that if there exists a x, that gives us the answer like 2 raised to x equal to the number n. That in this case, in the second case, it is 2 raised to 4 is equal to 16. So we are getting an answer. But in this third example, we are not getting it because n is 3 and there is no such x like 2 raised to x, it will give us 3. So we'll see the constant. Constant is minus 2 raised to 31 and 2 raised to 31 minus 1. That is a 32-bit integer basically. And there's a follow-up also and quite interesting. Can you solve it without loops and recursion? Okay, we'll try to do that. Okay. So first we'll try to write the powers. Okay. 2 raised to 1, 2 raised to 2 and 2 raised to and 2 raised to 4, and we'll also write their values. Okay, 1, 2, 4, 8 and 16. Okay, so did you see this is how we represent the binary number, like 1, 2, 4, 8. These are the bits, we can say, right? Correct. So this seems to be a bit manipulation problem. So we'll take few examples, like we'll take first 7, that is an odd number. Okay, so 7 we can represent like this. Okay, then we will take a number 8. Okay, 8 will be only 1, other things will be 0 itself. Okay, again we'll take a 6. Okay, 6 will be this 2 and this will be 0, and we take a 16 as we have in the example, right? So it will be 1 and the 16. Okay, so we can see this 7, does it match correctly with one of the number like 2 raised to power something? No, it has 3 bit set. So it's not a power of 2 because we have to add 2 raised to power of 2 plus 2 raised to power of 1 plus 2 raised to power of 0 to get 7. We are not getting directly like 2 raised to power of something is equal to 7, correct? Here 8. In this case, we are getting it. 8 is a power of 2, we can say, because 2 raised to power of 3, we are getting 8. So we can say that 8 is correct. 6 again, we are getting 2 bit set. So it's not a power of 2. Then 16, we can say yes, as we have seen in the example, right? So it's a power of 2. Okay, so from this we have observed that if a number have only one bit set, it's a power of 2. We can conclude this, right? Okay, so just we need to find if number n given has how many bits are set. If only one bit is set, we can say that okay, it's a power of 2 and we can return a true. So I'll just erase this part. Okay, and this is 1. Okay, so you can stop the video here and try to write your own solution and come back. And if you don't get it, you can follow the video. Okay. Then now we need to find it. So how to find the bits? So there is an algorithm, Branch-Kernighan's algorithm. Okay. So in that, what we will do, we'll take a number n. Okay, 3, suppose. So how many bits are in 3? We know that there are 2 bits, but how we'll find it? So in this algorithm, we will be doing 3 and 3 minus 1. So until the number is not equal to 0, we'll keep repeating this one. Okay. So I will show you what will happen when we keep repeating this one. Okay. So this is initially 3. Okay. And 3 minus 1 is 2. We are going to do an AND of this. So we are getting a 2 here when we do an AND. Then again we'll do an AND of 2 and 1 because 2 minus 1 is 1. So we'll get 0 here. So how many iterations do we do? This is 1 and this is the second iteration. So total we have 2 iterations, means 2 bits sent. So in this way we can count the set bits. Okay. So we'll dive into the code and write a code for it. Hope you get it. Then we just need to find out how many. So we can say like if we do once this like n and n minus 1, then the number should be 0, correct? If it has one bit set. If I have multiple, it will not be 0. So we'll just return n and n minus 1 is equal to 0. Okay, we'll just return this and hopefully it will work. Oh, it's working. Great. We'll try to submit it. Okay, we are getting a wrong answer. We'll use this test case for it. Okay, n is equal to 0. Okay, for these cases, we can say if n is less than 1, just return a false. Okay, when n is less than 1, we are returning a false and we'll try to submit it. Okay, yeah, we have beaten 100%. Yeah, that's a good solution. And also, what they were expecting, we have not written a loop or recursion for it. So this is the space complexity for this will be big of 1 only because we're not doing any loop or something. So that's all from my side, guys. If you have any doubt, please put into comment and I will try to help you and answer your questions as soon as possible. And see you in the next video. Thank you.